All right, so we continue with section 3.2. And we said we're gonna leave this one for class. Number 10 says find the exact values of all intercepts. So for we know a couple of things. We know that for the x-intercept, y equals 0. You guys remember that? And for the y-intercept, x equals 0. Yeah. So I'm going to find the y-intercept first. So I'm going to do work that. You know what? Let's do the x-intercept. So for the x-intercept, y equals 0. So if I replace 0 in my equation, I have 0 equals 2x squared minus 9x plus 9. And so I have to solve that quadratic equation. Okay, so I'm going to use the quadratic formula. And so my a is, well, let's write the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, I'm going to plug in my values now. B is negative 9. Notice the parentheses that I use help me keep my negative straight. And this is b again. A is 2, c is 9, and a again is 2. And now I'm just going to simplify. So this will be 9 plus or minus, x equals 9 plus or minus, the square root of 81 minus 8 times 9 is 72 over 4. This will be 9 plus or minus square root of 9 over 4. Which will be 9 plus or minus 3 over 4. Okay, so now when I get there, can I simplify? Well, can I add 9 plus 3 and can I subtract 9 plus 3? Yes, you can. So you do each of those. 9 plus 3 over 4. 9 minus 3 over 4. This will be 12 over 4 and 6 over 4. This will be 3 and 3 halves. Okay, so we found two values of x. Remember, right? This is x equals 3 or 3 halves. Now, what are the x-intercepts? Well, the x-intercepts are 2 points. We know there's 2 points because there's two values of x, aka two real solutions. Remember we said the real solutions is the number of x-intercepts, or did we say that? Yep, we said that goes with the number of x-intercepts right up here. All right, so we have two x-intercepts. So the x-intercepts then are, for one of them, x equals 3, and for the other one, x equals 3 half. What's the value of y, though, for the x-intercepts? 0, right? Okay, so we put those numbers in their place. Those are my two x-intercepts. Okay, and then I said for the y-intercept, x equals 0. So for the y-intercept, y equals, right, let me write x equals 0. Okay, so just my x is equals 0. So my equation becomes y equals 2 times 0 squared minus 9 times 0 plus 9. Notice the first two numbers are going to become 0, right? And you just have 9. So y equals 9. What's my y-intercept? Well, the value of y is 9. What's the value of x? You have wrote it right there. It's 0. Okay, so you have y-intercept 0, 9, x-intercepts, 2 x-intercepts. Yeah, by the way, so we know where the x-intercepts are. We also know that this opens up. That means our graph would be pointing in that direction, going through 3 halves 0. About right there, and then 3, 0. So the parabola would be going up like that. Okay. Notice we could find the vertex if we wanted to. All right. Let's start number 11, and then we'll finish it in class. Okay. So we'll just give it a teeny start. So a golf ball is hit so that its height in h in feet after t seconds is given by h of t equals negative 16t squared plus 60t plus 0.2. That might sound familiar. How long will it take the ball to strike the ground? And round your answer to the nearest hundredth of a second. Okay, so what does that mean? How long will it take the ball to strike the ground? So when the ball strikes the ground, that means the height h of t should be 0. And so you write your equation, this equation right here, with h of t equals 0. Remember, h of t is just y, so it's a single number, right? So our equation is 0 equals, I'll write over here, negative 16t squared plus 60t plus 0.2. Okay? And then you have to decide, do you want to use factoring or what method to use? Remember, we had various ways of solving a quadratic. So I'll let you decide that, and we'll finish that part in class. Let's go to section 3.3, complex numbers. So what are these complex numbers? So we define an imaginary unit first, I, such that I equals the square root of negative 1. Okay? Notice there is no such thing. That's why it's called an imaginary unit. So I squared then would be negative 1. How do we use I? Well, if a is greater than 0, right, some positive number a, then the square root of negative a, we can rewrite that as I square root of a. That's how we use it. Let's practice a little bit here. Let's try a and b. So anytime you see square root of a negative number, make sure you rewrite it first that way. That's the very first thing you do. Okay, so that means it applies right here. Square root of negative 16, first I say is I times the square root of 16. And then I simplify. This is I times 4, which we usually write 4i. Okay. Letter B, square root of negative 5, that's first thing I do is I square root of 5. And then I simplify, and I can't, so I leave it like that. Notice when it's an integer, I'll put the number on the coefficient on the left. When it's a square root, I'll put the coefficient on the right, so that the I doesn't accidentally fall under the square root. Okay, the other ones we will do in class, C and D. Let's try number 2, solve those three equations. So let's try, we'll do a couple. So let's try A, x squared plus 49 equals 0. That looks like I can write it x squared equals k. You guys remember that? And then just use the square root property. So I subtract 49. Let's write that. Minus 49 minus 49. And I get x squared equals negative 49. And so then x would be the plus or minus square root of negative 49. And we just said we can do that. X is plus or minus I square root of 49. So x equals plus or minus square root of 49 is 7. So I will write 7i. Okay, notice 7i is an imaginary number, right? We cannot count to 7i or stuff like that. Okay, let's try letter C, and then we'll leave B for class. All right, so letter C, x squared plus 2x plus 4 equals 0. So if I try factoring, the factors of 4 that add up to 2, there are none. So I'm going to then use the quadratic formula. So x then will be negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, and I'm going to plug in the numbers, and then we'll leave it for to finish in class. Okay, so b is 2, b is 2, a is 1, c is 4, and a is 1 again. All right, so we just need to simplify all that. Notice the quadratic formula is really just simplifying. You do need to remember it. If you're going to use it in a quiz, you'll need to memorize it, or a test. All right, so you finish that, and then you try number. We'll do leave B for class. Okay, let's go on to the last part here, the zeros of a function. So if f of k equals 0, then k is a 0 of f. Right? That means a 0 is just any value of x that makes the polynomial equal to 0. If k is a real number, the point k comma 0 is an x-intercept on the graph. Remember we said if there's the real solutions are x-intercepts, and the number of x-intercepts of the graph is the same as the number of real zeros, and we just saw that in the last section. Let's try the example here. F of x equals 2x squared minus 2x plus 1. And again, we'll start it, and we'll finish it in class. So determine the number of real zeros and the number of complex zeros. Well, we can actually do that by, you remember the discriminant. So the discriminant is b squared minus 4ac. And this will tell us how many real zeros we have, right? So that'll be b squared minus 4ac. So B is negative 2, A is 2, C is 1. This is 4 minus 8. That's going to be negative. I don't have to work it out. I already know that's a negative number. And if it's negative, that means I have no real zeros, right? Number of real zeros, none. So how can I tell the number of complex zeros? Well, if there's no real zeros, if it's less than 0, there's let's write this a different way. No real zeros. But because it's less than 0, then we know that we're going to get 2 zeros, but they're going to be complex or imaginary. Okay? Complex just includes the I part. Okay? So 2 complex zeros. All right. Letter B, find the zeros. Letter B, how do we find the zeros? Well, remember, it's where f of x equals 0. We just called it k up here, but it's where f of x equals 0. So that we just set f of x equal to 0. Yeah? And then we're just going to solve that equation. I'm going to leave that to you. Okay? And then find the number of x-intercepts. There's no real solutions. So letter C, there are no x-intercepts. No x-intercepts. Okay, so we have B left to do. And notice you can use the quadratic formula to get that done and find your values of x. Okay, they are going to be imaginary. We already know that. Yeah? All right, let's stop there. That's the end.